Hello, Assalamu alaikum bachon. How are you guys doing? Hope everyone is doing well. Today we are going to start our lecture number 4, I assume. Alright, lecture number 4. In this lecture we are going to get over the topic of fraction, decimal ratios and those kind of things. Pretty interesting topic. I really like this topic because I get a lot of questions about this topic from my students. The more questions a student asks about a topic, that's the topic that a teacher likes, because I get to know that they are involved in the topic, they are interested hearing what I'm saying. So that's one good thing. um, I want you guys to have a good amount of attention for this specific section, because this is where majority of your concept. Now, one thing about your O levels that you guys must be aware of till now, by now, is that your questions does not only, they are not loyal, they will not say that chalo sahi hai, from this particular topic we are putting one question. Nahi bhai, they don't believe in all this. They are gonna trouble you, they will put questions from here and there just to trouble you all. That is their whole purpose. That's what they were born for, that chalo sahi hai, hum log ko bachcho ko tang karna hai. That's what their whole purpose is. So this particular concept of conversions is very very important, because you will have questions where they'll give you things in percentage, convert to decimals, factors to decimal, बहुत ज़्यादा. This is something that is applied in majority of your question. All right, this conversion concept. So I hope everyone can give me their attention just for some time, then the rest of the session you guys can just chill and listen. Now, the first thing, I have color coded it very nicely. I'm very proud of it. So fractions are in green, decimals are in, I think, light pink, and those kind of things, blah blah blah. So when we are converting fraction to decimal, you just need to understand that 3 by 4, you guys have the calculator, so you guys don't have to worry much about it. But sometimes calculator does not do the conversion properly, so you guys need to be aware of. And those are the cases where it's the most extreme cases, where the questions are what do you say, the decimal point is way too big, or the fraction is way too huge for the calculator to do. So you simplify it and then you put it in the calculator and you get the correct answer. That again, those are extreme cases, which is very very unlikely. I think I saw one question in 2017 paper 2, something like that. So there was a question where the question was purposely put in so that the calculator answer is not the correct answer. You need to do some things manually and then you put the calculator answer and you get it correct. So again, as I mentioned, the sole purpose of examiner is to give you a hard time, but you guys must be prepared for that. Now, fraction to decimal, pretty simple. You have your calculator, you can do it through that. Percentage to decimal, whenever you're converting anything, any value from any decimal value to percentage, you always multiply with 100. All right, and if you have a certain value and you're converting to percentage, now let's say the sum of those, it's, let's say, the quantity, all right, quantity upon the sum, all right, upon the total, all right, multiply by 100 and you get the percentage. That's how percentages are solved. I'm assuming that you guys are here, so you guys must be knowing about that. Whenever you want to find a percentage of a certain quantity or a certain integer value, you take the certain quantity divided by the total quantity and multiplied by 100, and then you get the percentage of that particular quantity. You will have questions, we will discuss more questions about it in the further. I think you guys have pie chart or something, so we will discuss it. Again, just for now, this particular specification, did I post the specification? Oh no, I didn't post the specification. I think I did. Yeah, I did. Measures, did I think I didn't. Let me just check 1 second. Yep, I did not do that. Conversion, no, I think carry out conversion rate. I think this is the one. Shit, sorry. I didn't do the, alright, let me just paste it. It won't take long, but first let me just move this down. I forgot the decouple part. God, this is annoying. Alright, 1 second, bacho. Let me just move this to the next slide, and then let me paste the image. This is a specification that we have to discuss about this particular topic. All right, just a minute. All right. Now, in the question, they have stated that you will have some percentage, ratio, and proportion questions. These are the conversion that you guys need to know before we progress to that part, the ratio and proportion part. But this conversions that I'm speaking about, you will have these questions where they'll give you in decimal point and convert it to percentage. The other question that I was mentioning about where you will have quantity to percentage, that is a different topic. So again, we'll discuss in more depth about those later. And then percentage to decimal is here again, whatever the percentage value is divided by 100. So let's say if I have 50%, so I just take 50 divided by 100. All right, because if I'm converting something percentage, some decimal to percentage, I'm multiplying by 100. If I'm converting the percentage back to decimal, I will have to take upon 100. Percentage always means, percentage means, like the term percentage means out of 100. So again, whenever we speak about percentage, it's always out of 100. Now again, percentage of fraction, the same thing, the same story. Whatever the value is, 50 divided by 100, you just keep simplifying. Rather than going to the decimal, you just keep it as a fraction and then keep solving it that way. The same thing. You guys can go through the working that I've posted in the notes. I will also give the notes in the description in the Google Drive, so you guys can access it for the notes. Now yeah, that's basically it for this topic. And then now let's move on to the ratio part. Copy. All right, ratios. There are not a lot of questions of ratio in the paper, but again, it is a topic that is mentioned. Ratio, simplifying ratio, there are two particular things that you guys, two particular I don't know, techniques I would say, that you guys need to know about ratios. Ratios are very similar to fractions. The way that you treat fractions and then the way that you treat ratios are very similar. It's just like brother sister kind of story. Simplifying ratio, you just treat them just like fractions. However, let's say we have 12 and 18, 12 is to 18. You simplify 12 and 18, which is 2 and 3. Yeah, 6 twos are 12 and 6 threes are 18. Then you simplify and you get your final answer. All right, and then we have sharing the ratio. Now when we speak about sharing the ratio, I will be doing this question with you all. Now the question will say share the ratio $80 into the ratio 3:5. Now let's say your brother and you and your brother wants to share $80, and then since you are older, you're like, Naeem, I need to get the 5% ratio of the money. And then he says, all right, then give me 3% ratio of the money. All right, that's what we are going to discuss about. So now let's say ratio part A is to part B, and then we have the total. So part A must have ratio number 3. It doesn't matter ratio number 3, it doesn't matter where it goes. You can write 5 at the first as well, no problem. And then the total is the total of both the ratios, which is going to be 8. And then we are going to write the value that we are putting in proportion, which is 80. In this case, 80 is the total value. Sometimes in the question they will tell you that, all right, if the ratio is 5:3, and then John gets 80, John gets what, $30, then what is the total money that was split between them? So in that case, you just write the value over here, and then you see the difference. That we will get into that. Now for the first thing that we need to know is that now we wrote the total. After we have written the total, we need to see what is the ratio, like what is the ratio over here. In this case, the ratio is 10 multiplied by 10. We are multiplying that, we are multiplying with 10, and then we get $80. Now the same ratio applies to all of them. All right, now duplicate. All right, so we get I need to put these a little bit at the top. Yeah, now let's say the part A gets $50, and then the part B gets $50 and part A gets $30. So again, we know that the person who is in the part B gets $50, person in the part A gets $30. So as I have done the question this way, there will be other questions that you will be getting where they'll say that the person B has $50. What is the total amount of money? You just need to do the same thing. Find the ratio of the numbers and then just apply it to all of them, and then pretty much that's how you do sharing the ratio. Although I did a very simple question, it's just like the same concept applies to all the type of questions. um, when we do the paper, we will have a lot of practice, as I'm saying again and again, because I'm assuming that all of these concepts are just like for you guys to understand, and the main place where you guys are getting thorough is when you guys do past paper, because that's what I had done. I got to know the concept, I did some practice questions and all these kind of topic you don't need much practice question. When we start doing a little bit more difficult topics, that's when we start doing a practice question, and that's when it becomes more useful. In these kind of topics you don't need a specification, you don't need a practice question. And when you're appearing for your O levels, a student that aims for getting an A star or something, you must complete approximately, let's say, 15 to 20 papers. That's again minimum, that's the minimum, 15 to 20 papers. The maximum is again 30-35 papers is what I would say is a good number of papers for you guys to do if you guys are aiming for that A star. Because again, as I mentioned, paper 1 is a kind of paper where you guys must have muscle memory, a lot of practice. So what happens that by the time you get 35 papers, you are done with 35 papers, the paper, you guys know like what is the format of the paper, what are the kind of question that comes. You just see the few parts of the question and you guys know that, oh, this is what I have to do. That's what doing a lot of papers make you like, you know, get you that skill. Again, as I'm saying, O levels is pretty easy if you do a lot of practice, you take it seriously. I think O levels is quite doable. Now the next part is decimal places. Yep, this is also very important. I think this particular topic, this numbers unit, is just like a prerequisite thing, because like it gives you all the knowledge of like the kind of question that you guys will have. This is not even a proper topic, it's just like a gives you an idea, like, you know, prerequisite thing, gives you all the idea about what is yet to come and what are the things that you guys must know for all the questions. So it's a good unit, I would say. I have seen teachers that just skip the units, the number unit, because the unit of numbers, because they're like there's nothing to teach in that, pretty much they know it. But again, I feel that it is a good habit that I teach my students from the scratch, because you never know who knows what. So I don't like that kind of mentality. So again, if you guys know these kind of things, feel free to skip it, but at the same time, if you guys just see it again, there's no harm. All right. Decimal places. All right, decimal places, always look at the right of the place that you are rounding. If it is more than 5, then round up, and if it is 4 or less, then just keep it the same. So when I speak about that, now the question is, let's say 8.3726. The question asking that you need to give your answer in 2 decimal places, 2 dp. So what you do is you take this value. Now let me put it red. You see this value. All right, this is my value, and then I see the next value. Now this is my second decimal place. Now from second decimal place, I must look at the third decimal place to check if it is more than 5, then this becomes 8. If it is less than 4, or if it is 4 or anything less than 4, then I'm like, okay, this stays the same. If it is 5 or anything more than 5, it becomes 8. All right, I hope that was clear. So in this case, it is less, so it just like what do you say, it's going to stay the same. Now another thing, significant numbers. Many students get mixed up with significant numbers. The simplest way to remember about significant numbers is always start from the first non-zero digit from the left. All right, so let's see. Now this is my left, I'm starting from here. Now my first non-zero value is 5. All right, now the question is saying 2 significant figures. So this is my first significant figure, this is my second significant figure. So after this second significant figure, I must look at the next part. Is this more than 5? No, it is not more than 5. So this stays the same. If this was more than 5, it would be 58,000. All right. Now let's look at the second question. Like it's another question. Here is where I'm starting. I'm starting from here, left side. All right. Now is this significant? No. Is this as non-zero value? No. So again, we move forward. Is this 0? Yes. Is it a non-significant? Is it significant? No, it is not. Is this 0? Yes, absolutely. Is this significant? No. Now here, the criteria was non-zero value. So in this case, this is a non-zero value. So here is where my significance starts. So this is one significant figure. This is two significant figure. Now when I want, if my question was two significant figures, now I got my two significant figures. Now I must check at the third significant figure value to check what will be my second significant figures number. So this is going to be, will it increment? Yes, in this case it will increment, because 0.0041 will be the answer, because in this case the next value is greater than 5. If it is greater than 5, then you must you must increment. All right, this is what you guys had to know about decimal places, decimal, the ratio and decimal. I'm not ratio, sorry, significant numbers and decimal. Let's move on to the next specification. Oh no, shit, I forgot to mention the specification for this one as well. I don't know what's happening, man. Today I'm forgetting things. Crazy. Let me just put that right here. Let me just pull this down a little. Yep, this is fine. Alright, this was the specification specifying numbers in the given degree of accuracy. Now let's move on to the next specification, which is very interesting. Here we go. One second, let it load. Here it is. Now the question, the specification is about solving problems using upper and lower bounds where the values are given to a degree of accuracy. Alright, now degree of accuracy is what we studied last specification, where we studied degree of accuracy, which is decimal places and significant numbers. Now we are going to start studying about upper and lower bound. Upper and lower bound is because now when we are doing now why do we study about upper and lower bound? What is happening in upper and lower bound? The thing that you guys must know about upper and lower bound is that when a number has been rounded, we do not know the exact value of the original number. We don't know like the exact original value. So now let's say if we rounded off 5,000, 50, this became 57,000. So I do not know these values, correct? So that's why we do lower bound and upper bound, to avoid that that error that is happening. All right, now again it is it's a topic that you guys must have must know, because it is there in the question. All right, let me first let's take the concept, which is this. All right, copy. Let me paste it. Okay, so again this has a formula. All of these formulas are mandatory for you guys to learn. If you guys do not learn it, you guys are going to face difficulty in your paper. So I would highly recommend you all to learn this formula, because these it's not very difficult. So now let me explain you guys the easy way. For addition and multiplication, alright, for addition and multiplication, it's the same thing. So for upper bound, you always upper bound plus upper bound. For addition, lower bound plus lower bound. For multiplication, again, if you want upper bound multiply by upper bound, lower bound multiply by lower bound. When you're doing division or subtraction, that's when the laws become a little bit different. For upper bound, you always take the bigger value as upper bound, and then you take the smaller value as a lower bound. And then when you're doing a lower bound, you take the lower bound of the bigger value, and then you take this upper bound of the smaller value. All right, I hope that was clear. Again, when you are finding the upper bound in a subtraction value, when you're subtracting and you must find the upper bound, you take the upper bound of the bigger value and then the lower bound of the smaller value. And then when you have to find the lower bound value in subtraction, you guys must do subtraction to find the lower bound. In that case scenario, what you guys have to do is you guys take the bigger value of the lower bound, the you take the upper bound of the smaller value. All right, now when it is division, you guys need to find the upper bound. In that case, you take the upper bound divided by the lower bound. In the denominator, it will be the lower bound. When you're doing a lower bound in division, you guys must take the lower bound as the top value and upper bound as the lower value. Okay, now this is related to the this particular thing. It is related to the question that I solved. Now let me just copy. This is a practice question that I had previously done it. Let me just paste it over here. All right, now the question is saying, can I utilize the space? Yes, I can bring this one up. Yep, that looks neat. Now the question is stating a rectangle excuse me, the question is stating a rectangle measures length is equal to 10 centimeter and a width is equal to 8 centimeter, both to the nearest centimeter. Find the upper and the lower bound for its area. So now again, this is what I have done. I have made this into rows and columns. If you guys do this, I guarantee you guys will have a higher level of accuracy, because this really helped me. I never did any mistake in lower and upper bound question, because this is the format that I used to follow. And another thing is, now you guys must understand that in all the question they will tell you the degree of accuracy. So in this case, the degree of accuracy is nearest centimeter. All right, when we speak about nearest centimeter, nearest millimeter, we take 1 centimeter. All right, we take 1 millimeter, 1 kilometer. If they say that already this is like, they mention it to you that the significant value is that 1 centimeter or something, they mention it in the question clearly. So in this case it is nearest centimeter. So nearest centimeter, 1 centimeter divided by 2. This is what I have mentioned. Find the degree of accuracy, half it, and then add and subtract from the rounded numbers. Now in this case, my degree of accuracy is 1 centimeter. I divide that by 2 and then I get 0.5. Now for me to find the upper and lower bound, I just need to subtract 0.5 for finding the lower bound, add 0.5 to find the upper bound. All right, and many times, not many times, sometimes you will also get questions where they will give you 2 different degree of accuracy for 2 different values. That is also a possibility. So don't get scared like, oh shit, what happened. Those are also the kind of question that comes. All right, so in this case I found my lower bound and upper bound, which was over here. It was 10. Let me just write value. This was 10 and the width was 8. All right, so I found the lower bound, I found the upper bound. All right, and then now the question stated, find the upper and lower bound of its area. Now I found the lower bound of the area, which is, I took the upper bound multiply by the upper bound, which was 9.5 multiplied by 7.5, and then in this case upper bound area was lower bound, and then the upper bound area was 10.5 and 8.5 here and here. All right, I might say something wrong, like, like my verbally I might say some things wrong, but then you guys must just look at the things that I'm pointing out, because I don't know, I'm getting confused. But the point is that my working is correct and what I'm pointing is correct. I think the thing that I'm saying just gets mixed up sometimes, so I apologize for that. But yeah, this is basically it about upper and lower bound. Pretty interesting topic. Again, at the same time, it is something that you guys must have not came across earlier, because it was something that I don't think so they teach you in lower classes. But it's a very interesting topic and very informative one, because when we round off a value, we remove all the previous values. We just, like, rounding it off, but then we don't realize that, alright, when we are rounding it off, we are losing a lot of original values. So that's what the whole idea behind lower bound and upper bound is. All right, now let's move on to the last specification for this unit, which is numbers in standard form. You guys must know how to write numbers in standard form, and why is standard form used. I'm going to explain that as well. Just a minute, let me just paste this. Now standard numbers are used because when you have numbers so big, like so huge, you don't have to write 0.00001. You don't have to write. If you have 10 million, you don't have to write 110000000. So what that does is, what standard form does is it simplifies those kind of numbers and lets you write in a simpler way. All right, so here it is. Let me just copy. All right, stay here, and then let me just copy this here. Now this is the format that you guys must be aware of. Now let me explain you guys the format. So a is a value, any value, all right, any value from 1 to 10. It cannot be any value from 1 to 9. It cannot be 10. All right, again, you guys must be thinking like, what am I saying? But once you guys start doing the question, that's when you guys will understand what I'm trying to mean. Your value of a must not be 10. It can never be more than 10. It must always be lower than 10. It can be 4.7, 4.8, 9.9, but it can never be 10. All right, that's it, because that's how it is. When you guys will do the question, you guys will understand, because if you take 10 and you're writing it in standard form, there's a decimal point over here, so this 0 goes away. So it can never be 10. It can always be 1 to 9. It can be any value from 1 to 9. All right, and then n is an integer, which is the power. It can be integer. When I say integer, it can be negative value as well. All right. Now big number. When we have big number and we are converting to standard form, the decimal point moves. All right, let me just write it in a big way so that I can explain it. 4700000. All right, in this case, always remember that the decimal starts from here. The decimal always starts here. All right, the decimal always starts here. All right, and then this decimal point now moves 1, 2, 3, 4, 5. Correct? Now since it came here, all we do is we remove all of these zeros, multiply by 10 to the power of 5. I hope this was clear. I hope you guys understood. Let me explain again. No problem. Let me explain again. It's going to be 4700000. You have a point over here. All right, always, if it is a whole number, if it is a integer value, a whole number, a natural number, positive value, always it starts from this side. Now one way to remember is that, okay, if this is a whole number, always has this kind of value. It is written like this, but then these values are not written because it does not have any significance. But although in the world of mathematics this is what it looks like, so that's why the point is always here. So this point moves 1, 2, 3, 4, 5. This is where it comes here and stops. All right, because we need value for standard form. If I move this over here, it becomes invalid. It is wrong. We cannot do that, because remember the range that I spoke about. It must be greater than 1, but it cannot exceed 10. All right. So in this case, 4.7 satisfies that criteria. All right. Let me criteria multiply by 10 to the power of 5. All right. Clear? Now this is one way to write it. And when we are talking about small numbers, which is in this case we have 0.00081. So the decimal point is already here. They have given you the decimal point. Now when it is moving towards the right, the value of the power becomes negative. All right, 1, 2, 3, 4. All right, now these values gets removed off, multiply by 10 to the power of negative 4 if it is moving towards the right, because this jumped towards the right to make it a standard form. So our value is going to be negative 4. All right, if it is moving towards the right, it is negative. If it is moving towards the left, it is positive. All right, and with this specification we are done with the unit of numbers. The next unit that we are going to start is sets. That is a very interesting topic, the sets. It is also a topic where many students do a lot of blunders, so we are going to give extra amount of explanation and a lot of questions in the sets unit. But again, it is a very interesting topic. So yeah, we are done with the unit of numbers. I hope you guys understood everything I've explained. I tried my best, and if there is any more queries that you guys have, please feel free to ask me.